of introverted coders here, but let's try one more time. How are we all doing this evening? Thank you especially for your very gleeful cheers. I love it. So for those of you who are probably wondering, how many of you guys know what Galvanize is? All right, so like half the room just wandered into a building and not knew what they were walking into. So of those of you who raise your hands, who can probably give me the best spiel of what Galvanize is? Who dares? Who dares? We will totally judge you, by the way. It's like an air gap at this point. Anyone? I believe you raised your hand, didn't you? Oh, don't shake your hand now. Which order you raise your hand? Come on, be brave. Yeah, go for it.
I believe originally a co-working space.
With an accent as well.
With various sessions and seminars and events such as this one. And there's also the Galvanize University, I think, the G School, running courses.
Let's see how good our marketing is. Keep going. What else?
Things I can offer you.
Not too shabby. Yes, I think a lot of that is correct. So Galvanize is actually a multi-campus company that offers multiple things that help you level up. So among our offerings are educational programming, if you want to learn full stack coding or data science, collaborative spaces on our 4th and 5th floors that are gorgeous for your startup or your business or what have you. Event space, or actually events themselves, such like the one you're attending. And also, if you're interested in venture capital as well. So we try to do a little bit of everything to have all you need under one amazing roof. Specific for this, we're very interested in also our educational initiatives. We consider ourselves an educational company first and foremost. So if you're interested in our full stack development program, it's a 6-month immersive program that turns out a 98% job placement rate and an average starting salary of $73K. If you're interested in our data science program, which is launching very soon, its next cycle in October, it's an average starting salary of $115K and also a job placement rate of 93%. So if you have any other questions, you can come talk to me. I've got 4 business cards listed over there because I'm ordering some new ones very soon. Or you can ask more about us at info@galvanize.com. So without further ado, I'm going to go ahead and introduce to you Seattle Spark Meetup co-founder, currently conversing, has no idea that I'm talking about him right now, Denny Lee.
Well, say what? Yeah, let's go. How's it going, everybody? Do I need to do the mic? Or do I not need the mic?
No, you don't need a mic.
All right, no mic. All right, cool. So this is me actually going to show slides for once, and they're actually useful. At least I think they are. I'm about to drop the mic. Okay, cool. Apparently, I do not know how to plug in an HDMI cord. Cool. So,
Is it on?
Is it on? Ah,
It's
there.
asleep.
We didn't bother turning it on.
No, it's asleep.
Okay, let's wait for that. But then, okay.
Waited for too long.
Okay, cool. Let's see. All right, cool. Well, while we wait for that, first of all, I want to say thank you to all the volunteers who actually went ahead and. So for starters, we want to thank Galvanize for this awesome space. So a round of applause for these guys. We also want to thank Lee. He's actually the person you actually care about, okay? Because he's actually going to provide you information as opposed to somebody like myself, which is useless, okay? So thank you very much. And also NFL Labs for the pizzas and drinks. So thank you very much. And also to people like Felix and Ryan, who are the constant volunteers who are helping us keep running Seattle Spark Meetup. We're actually about number, I think, 15, okay, of the Seattle Spark Meetup. So we've had quite a few, and we're actually the second most active meetup, Spark Meetup in the world, to give us context here, okay? So, a round of applause for these guys, okay? Now, first things first, the thing shows Spark Hub. Basically, if you want to know some information about Spark, go to Spark Hub. But the real thing I wanted to show was the Spark Summit Europe. In case you guys are interested, Spark Summit Europe is in Amsterdam this year, end of October. And if you're interested in using a promo code, use that code. I'll actually send it out to you guys, which gets you 20% off. Okay, so we've got some really great speakers, including Moon, to go ahead and speak, who will be speaking at this, the Spark Summit in Europe. Okay, it'll be our first one in Europe. We shortly after the Hadoop folks did theirs, and it seems like a pretty popular one even in Europe. So we're actually sort of impressed with that fact. Okay. All right. We have some quick upcoming sessions as well, and we want to call that out for all you guys too. We actually in 2 weeks from now, we're actually going to have one in AWS. This is creating Create powerful parallel process solutions with Databricks and AWS Kinesis. Sorry for the super long title. But basically, it's actually a call out about how to utilize Kinesis with Spark Streaming, and also it's a customer case story. So we actually have Francis Lau from Smartsheets, who's actually going to be coming over to speak about his experiences. So if you're interested in learning how to combine those systems together, there's the regular spiel that we're going to do, but there's also the more important part, which is Francis to talk about his key learnings of how to use Kinesis with Spark Streaming. Okay, so that'll be in a couple of weeks at the AWS offices. There's also the unstructured data science pop-up in Seattle, okay, in Galvanize. Okay, so we'll be here in, October 7th? I should look at my own slides. Okay, so there'll be an all-day event plus cocktails. For those who are interested, there is also a code for that. Use Domino Data Lab for 20% off to come to that. There's a bunch of speakers, including myself, Amanda Kasari, Al Steng, and David Talby. The reason I'm calling those good folks out because they are people who have already done Seattle Spark Meetup sessions as well. And so they're going to be speaking at this event as well. Okay, so, okay, and we got more. Okay, so in October, we have a machine learning on Spark roundtable. We're going to have a panel of at least 7 people to talk about their key learnings and their key experiences about machine learning. So if you are interested in machine learning, again, I would have you guys come on over and have your questions ready. So we are doing sessions in which we're speaking, but it's actually designed for Q&A. So in other words, ask your questions, be prepared for that, okay? And then we also have a webinar on October 20th. This is transitioning from traditional data warehousing to Spark in the OR predictive modeling. Long story on short for that one. Basically, it's a healthcare predictive analytics project over at Care Group Healthcare. Care Group Healthcare basically is the IT shop for Harvard Medical Schools. Basically, they're calling out how they went ahead and transitioned from a traditional SQL data warehouse solution to building the solution in Spark. So we're going to hear a little bit about that. Full due diligence. I'm actually one of the speakers too. So. Okay, and then at the end of November, early November, we also have a cool titled "A Journey to the Center of Big Data with Spark and WebTrends." So for many of you, I don't know if you knew this, but WebTrends actually has a number of committers to Spark, and they've been committing for the last 3 years, actually, into Spark. And so we've got a bunch of people who are coming up from Portland specifically to talk about it, including one of the main committers, Sean McNamara. But also we've got 2 other folks from WebTrends who are actually planning to speak as well. So we've got some key learnings about how they went ahead and built their Spark system. Okay, that again, questions that you may have, key learnings that you want to learn about. This is a great session to talk about that. Okay, and we'll also do a quick summary from the best of Spark Summit Europe because November 11th, that'll be 2 weeks after Spark Summit Europe is finished. So for those of you who couldn't attend, we'll actually make sure we have a little summary session for you guys. Okay, so that way we at least tell you what were the cool sessions, what were interesting. All the slides and videos for Spark Summit Europe are going to be made available on the Spark Summit site anyways. So the idea is that we'll just call out some of the cooler sessions so you can actually see which ones that might be interesting. Okay? Any questions before I go on? Because there's a little bit more. No? All right, cool. All right, so we have planned sessions for Spark Jeopardy. It'll be in December. We're going to either do it at the Facebook offices or Twitter offices. We haven't decided which one we're going to do yet. But basically, that's planned for December. And then I want to raise a hand. So in other words, I want your help here. Okay, are you guys interested in like a Spark and R joint session? Are you guys interested in that? Okay, good. All right. How about a Spark introduction workshop? Okay. Are you guys okay with an hour, or you guys want 3 hours, 4 hours? An hour workshop. Okay, 3 hour workshop. Okay, cool. We know what to build. All right, cool. Do you guys want to see more real world case studies?
Yes.
Okay, excellent. We'll do that. We've definitely got plenty of those coming up the line. And in fact, like I said, WebTrends is a good example of that. Spark operations. Are you guys interested in the operational aspects of things? Okay, a few. Okay, we'll still do it. How about repeat sessions like the ones for eBay and Tune? You guys like those? All right, cool. All right, that just to give us an idea of what type of sessions you're looking for. So we already have everything planned out for this year, as you can sort of tell, and we actually had to do double 2 per month, which we don't like doing because logistically it's a nightmare. But by the same token, we know this will give us an idea of what sessions for us to plan for in the new year. Okay? All right. So my final little spiel before we go to the star of the show is that Spark 1.5 just got released this morning. Okay, so because of that, I just want to commemorate the top 5 of Spark 1.5. Okay, just a quick call out on why you guys should switch over to Spark 1.5. Okay, and so The key callouts is data frames. Why? Because it's a unifying data structure. It's also really, really fast because of the fact that we're utilizing tungsten. So I'm not going to get into the deep spiel about how cool and how fast tungsten is, but what I can do is say something like, if you're using between 1.4 and 1.5, for one of the test cases I just ran recently, if you were actually to use things like statements, date statements, things like that, to actually, because you want to filter and slice by, it's actually twice as fast. Okay, using tungsten in 1.5 and 1.4. Okay, so we were seeing distinct count calculations and count calculations running significantly faster because we're using tungsten. So that's a great reason to use 1.5. Okay. Another great reason is that basically because we're doing code gen, that's actually how we do it. Okay. There's also memory management and binary processing, and most importantly, we improved a bunch of the issues surrounding cache-aware computation. Okay. 3, streaming back pressure. Basically, the idea is that as you hit back pressure, when you're running your streaming, when you're running your streaming and you're hitting memory pressure, the idea is that the back pressure code that we put in signals to the system to actually reset the way Spark works. So that way, even though we might be crashing or rebooting a bunch of processes, it's completely transparent. So that way we can actually go ahead and continue still processes because we actually activate some other tasks, some other nodes, to run the system. 4, windowing functions, one of the most popular questions that was asked from us to go ahead and improve. So there was a whole bunch of blog posts actually on databricks.com/blog where we talk about all the additional windowing functions that we put into Spark 1.5. Okay? And the 5th one is, don't worry about that. 5th one is ML pipelines. Again, we've actually improved the way ML pipelines work, so it's on par with the scikit runner. Okay, so there are a lot of things that we're trying to do to make it even easier for data scientists, for analysts to actually make use of Spark. Basically give you the ease of Python, but actually with the performance of Spark. Okay, so that's it for me. Sorry, question?
Are your slides going to be available after?
Yes, they're absolutely going to be available actually, so no worries on that. So that's it. I talked a little bit too long. Without ado, move.
Yeah, and actually Denny missed the number 6, which is SparkR improvement, but I'm going to be talking about that very soon.
All right, rock on.
Thank you.
Hello, my name is Moon, and I came from South Korea, and I'm one of the creators of Apache Zeppelin, and I'm going to talk about data science lifecycle with Apache Zeppelin. But before I start, I need you to understand that my English is not really good, so I'm still learning. But please understand this one. But my Korean is not really good too, so it's So the talk is about data science lifecycle with Zeppelin. So what is data science lifecycle? This diagram is what I found from Wikipedia actually, so it's not what I'm saying. But other people say data science lifecycle is a bunch of these steps, from data collection and storing data and cleaning data and exploration and making a model and algorithms and making a report and share, and that results generates another data, and it's a lot of different jobs need to be done. So usually, especially with large set of data, you will need a lot of different technologies and a lot of different software stacks, a lot of different people who can take care of all these steps. So you will need maybe 10 or 20 different softwares to build this life cycle. And inside of this life cycle, the people who are in is not only engineers or software developers or data scientists, but also there are some consumers like your CEO or your marketing team or sales team will be part of this life cycle. So a very complicated life cycle. So that means you want to do some meaningful job, but you don't have time for that. You will spend most of the time to fix this, all the different softwares, and you will need to spend most of the time to install and deploy and configure all the difficult things. But thanks to Apache Spark's generality, Spark had really nice computing framework, and on top of that, he handles a lot of different workloads from SQL and streaming, and machine learning, and graphical processor. So thanks to Spark really changes how people process the data. That's it, at least I believe. So, but the whole life cycle is not covered by Spark, I think. So Spark changes how people process the data, but the rest of the life cycle is actually how people use the data. It's about how people use the data. So, and that's where Zeppelin wanted to be in, and Zeppelin wanted to be changed. So how Zeppelin have a lot of nice features, like it supports multiple different backends, like from Spark to Flink and many other different frameworks. And also it's got interactive notebook, and it's got built-in visualizations, and it's able to load some useful libraries, and it's supporting sharing. But not only Zeppelin alone, but also with a great ecosystem around Zeppelin. And for your information, Zeppelin is a relatively new project. It's just it's Apache incubated since last December. So since that time, we have built all these ecosystems. So there are a lot of many projects or products that packaging and deploying Zeppelin, and there are some services that on a cloud that includes Zeppelin, including Microsoft Azure, and there are a lot of interpreters. Interpreters are Zeppelin term that means backend integration. So Zeppelin supports not only Spark but also many other different backend systems. So there are actually more than 6 right now. We have 9 of them in source tree, and more are on our pull request working in progress, and there are many others in ecosystem. I'm gonna handle later. So I want to do a quick demo what Zeppelin will look like, and I'm sure many of the people here already know about notebook system like Python notebook or database cloud. So I'm not going to go really deep, but I just wanted to go to the quick demo. So this is notebook inside of Zeppelin, and I want to load some data. Yeah, it's fortunately finishing, and I can use Spark SQL over this data I have loaded. And Zeppelin have a built-in visualization, so you can just click the buttons, and then Zeppelin will load a chart, and it's got also nice keyboard function inside, so you can play around with this your result data, and maybe I can create more charts from maybe this time. By the way, this data is customer data from the bank and what's the age of customer and what's their balance and their balance and so on. So I can create these two charts, and then maybe if I have some people I can work with, then I can send this URL so my coworkers can see the same document, same notebook, and what I see is what he sees, so I can collaborate with some people. And maybe once I'm done with my job, then I wanted to, I'm not doing this job just for fun. Maybe sometimes I can, but I eventually need to send this one to someone who need it, like sales team or your CEO or someone. So I can format this as a nice report format, and I can send this URL to my people. Then 10 minutes later, you will get response like, "Oh, thank you, this is really great." But next 10 minutes, he will ask, "Can you change this?" So then, yeah, it's not difficult. I can just reopen that notebook, and maybe he wanted to just see who is age older than 30. So I changed it and I shared it again. And then he will ask 5 minutes later, can you change it actually to 50 or something? So instead of keep changing, because that is consuming my time, I can put some parameters here, and my boss can change himself here. So I don't get bothered anymore. So this is a quick short demo of how Zeppelin is look like. So it's definitely helping. I think it's definitely helping people process the data and how use data and how share the data. And so this is the goal of Zeppelin, and I think Zeppelin definitely helps. But many people actually, a lot of people, last June, I had a Spark Summit and Hadoop Summit, and I get more than 200 questions, the same question. The question was comparing Zeppelin with IPython or data with cloud. So people keep asking, what's the difference? Because of the notebook, same notebook, so what is the difference? So after that summit, I asked myself the same question, what is the difference between these notebooks? Yeah, there are a lot of differences. Zeppelin is Apache open source, and for example, IPython is open source, but it's not Apache. And Zeppelin is based on JVM, and IPython is not. And a lot of different details, but I think it's not the core of the differences. I was thinking, what is the core of the difference of these tools that ships Bluetooth inside? I think the difference is that Zeppelin is trying to change how people use data. I think that's the difference. I'm not sure how IPython people think about their roadmap. But I'm sure that Zeppelin's goal is not clearly not making the best notebook in the world. That's not Zeppelin's goal. The goal is change how people use data. So I changed the question. So from how different Zeppelin is to how close Zeppelin is to this goal. So this notebook is enough to solve this problem. So I changed the question to how close it is, Zeppelin is, and I think it's still far from changing actually how people use data, because of in data science life cycle there are a lot of people, a lot of different people, not only a lot of different software, but a lot of different people like your boss. He can see and change some numbers in just in notebook, but actually he's limited by what data scientists created. He needs someone's help to use Zeppelin. So I wanted to go beyond the notebook. So that's this proposal is actually published by today. So this is first time I'm talking about this proposal in public. So this is called Helium, and it's a platform for data analytics application on top of Apache Zeppelin. So it's an application platform, and application here means algorithms and view. So not only your backend logic code that process your data or analyze your data, but also your application must have nice graphical user interface, otherwise your boss will not be happy about it. So Helium application supports not only algorithm but also view. But the one reason he must on top of Zeppelin is because of Zeppelin provides some resources to your application. So what can be the resources? The resource can be either data can come from last execution of your notebook, or some backend system, or the resource can be computing resources. So it can be a Spark context or Flink environment and any other computing resources. So that means your application can use data provided by Zeppelin, or and also your application can use processing power provided by Zeppelin. And actually, the resource is not limited by these two. Resources can be anything that can any Java object can be resources. So what is possible with this Helium framework? So one thing I can think is application can generate data, can produce some data with this framework. And I have one example application that produces data from Git repository. And another type of application possible is application can actually process something using computing resources provided by Zeppelin. So I have another example that application using Spark and distributing the code. The code is monitoring CPU usage of workers. So application is Spark clusters CPU monitoring using Spark itself. And the other possible application is consuming the data. So application, one great example is consuming data is visualization. So I have an example of that. So I have actually working proposal of Helium that I proposed this morning. So to run Helium, I can just run these launchers, and then depends on the resources available, it automatically suggests possible application I can run. And I have let's first try to run Spark monitoring application. It's monitoring Spark CPU every seconds. Yeah, this should work, but it's not working. And this is the beauty of live data. So, this is for sometimes happens, but
It's by design.
yeah. Let me check. Yeah, it should work.
Is it a network issue? Like your Wi-Fi is offline?
Maybe. Yeah, I maybe probably have to fix it, but yeah, basically it's going to use a Spark context that is provided by Zeppelin. And another example is actually this one. I hope this one is not blinking. And this is loading commit messages or any commit history from this repository, so we can use it.
Just you're not going to Is it connected to your phone?
Yeah.
Don't have time. Okay, so
Yeah, I think yeah, it's okay. I have backup, so I do have a video, fortunately. Hope I can play this video.
You don't have network, I think that's...
Turn your Wi-Fi.
No, turn on Wi-Fi. I think you turn it off just now.
Okay. So I have a video, the same video I'm trying to do. So this is the example of the Spark CPU monitoring application. It's the video is actually having some kind of buffering, but you can see it's keep updating, constantly updating CPU usage of the cluster, and I can have my custom some control or any other interface on my application. So in this case, I have some buttons to change the interval of monitoring, and then yeah, this is a key. Once it's downloading data from Git repository, then I can switch to normal root context. So I can get those data from application to my Spark code. I can play around with my Spark code with the data that the application loads, and then I can when I'm still playing. And then I can actually run visualization application out of my Spark processing result. So this is the visualization not built in inside of Zeppelin, but it's loaded from the application framework. So in this way, I think not only data scientist or software engineer or some really skilled person, but also if there is a lot of nice application, then I think normal person can use it and play around the data. So this is I think where Zeppelin wanted to go, at least to me. And there are some technical details, but I'm gonna skip this one. And I think this is a really good example that how you can get involved. Because of Zeppelin is open source, you can participate by using Zeppelin or by giving feedback, by giving some idea, suggestions, and joining discussions or contributing code and documentation. So you can actually participate on changing how people use data. So it's a really easy way to change people. And the Helium is one example that I created a proposal and I'm gonna publish it to community, and I'm gonna have discussion and people will get involved and improve this idea based on my code. and then a lot of ideas and contributions get accepted, and then we will have this framework. So hope everyone here can get into the community. And this is my talk. So I'm going to hand over to Felix. Thanks.
We can try to have a little Q&A at the end if people want to stick around a little bit. Let's see how long we can do this. Turn this on. Yeah. Let's see if I can get it to work. Okay. Let's see. Slideshow. That's weird. Okay. So here we come to the second part of the talk we have today. I'm Felix. About a little bit about myself. I've been contributing to Apache Spark and Apache Zeppelin. And I'm pretty big on the open source space. I'm really passionate about, working with the community, actually building new things. So I'm really happy that there's a good community here. People are interested in Spark in general and coming here. So thanks for coming. So a quick agenda. Today I'm going to talk about a few things. So I want to do a quick introduction on R and SparkR, and then SparkR with data frame, which is kind of relatively a new thing. And then we're going to quickly dive into a quick demo with our interpreter in Zeppelin. And then we're going to leave off with what's next coming up. So before we go there, I want to kind of do a quick show of hand if who is familiar with R and who's using R on a daily basis. Not a lot. So I guess not a whole lot of you actually know or use SparkR then. So this could possibly be a great introduction, I guess, in terms of R and SparkR in general. So about R, first of all, R has been around for quite some time, as you can see. So R is a programming language for statistical computing and visualization and that sort of stuff. So R is based on S, so you can kind of tell S, R, S. Anyway, so the fourth version of S is called S4. Obviously, for I don't know what the reason is, but it's basically a object-oriented wrapper around the previous release, which is called S3. So R is based on S4, and then it added like lexical scoping, that sort of stuff on top of it. So, but if you dive into the core of R, you're going to be exposed to a lot of the S4 and S3 stuff. But at a very high level, R is a interpreted language. It has very good matrix arithmetics. You can use R for similar to how you can use MATLAB and Octave, that sort of thing, which is kind of built around matrix, all that. And so this is kind of similar to that. One great thing about R is that there's a huge repository of packages. There's like one really popular one called Crane, has 7,000 plus packages. You can pretty much find anything you want, and any kind of utility library, machine learning, and that sort of thing, whatever you can think of, it is there somewhere. So why do we even care about R with Spark? So one thing that people talk a lot about is Spark is very good about processing data, and in a way that's very scalable and has a lot of flexibility. You can actually plug in sort of different workload and framework and library and things like that on top of it. What R is really good, on the other hand, is that it's really good around like if you want to compute statistics, huge ecosystem with like 7,000 packages and whatever you can think of it's there. And it's very good about interactive analysis. So you can actually use it, and we're going to be actually doing a quick demo of that. So the two of them add together is actually a great way to leverage the power of Spark and process data in a scalable kind of manner. At the same time, be able to like interactive and use the existing ecosystem out there for the packages that's out there. So, so SparkR is our language binding for Spark and Spark SQL or data frame. So it exposes functionality in a R kind of friendly kind of manner around the data frame API. The two usual way you can go around doing this, there's a special command line REPL you can run called SparkR. You can just run it if you have the Spark 1.4 and above release. And then, or you can actually just load it like a normal R package within R itself by running these lines of code. So before we dive into a little bit more around the high-level structure of SparkR, a little bit of history on SparkR is actually started as a research project about a year ago by a couple of folks in AmLab, which is actually also the birthplace of Apache Spark. So AmLab, UC Berkeley, they started actually building this API set in R code around the LDD API, which is kind of much lower level than what you have right now in the current release. But you can do operation like transformation, map, future, that sort of thing, if within that release of SparkR. And then it evolved throughout the year, incorporating new data frame API, schema LDD, which get renamed into data frame, and there's a new API around that sort of thing. And Spark 1.4 is actually the first release where SparkR is officially part of the Spark release as of 2 months ago, I think. And then Spark 1.5, which, as you've heard, just got announced and released as of this morning. So, and we're going to go back to that a little bit more about like what's new in 1.5, and that's going to be part of my demo. So, very high level, the architecture we're talking about, in some ways, really similar to the Python binding with with Spark. So, in SparkR, there's a layer of all these native classes that you can use to operate on, but it talks back into a R backend that's part of the JVM process where most of the heavy lifting is actually being done. So when you run SparkR in cluster mode, what happened is the drivers running your program and the processing happening on your worker node or your executor running your R code and doing some processing, heavy lifting in a distributed, scalable kind of manner. So the advantage of this approach is that you get best of both worlds, right? You get all the nice outbinding that people are used to, so you can manipulate Spark data frame in a way that's kind of you're familiar with. At the same time, you get all the power of JVM and all the optimization that that, for example, Denny talked about in 1.5 release. In addition to the Catalyst engine, which is execution plan optimization, but tungsten and all these optimizations that happens in the next release. So one of the branch map that was done about a month ago with SparkR and data frame is that we kind of seeing basically the same performance characteristic as what you would get running a Spark job in native Scala code. So it's comparable. I mean, don't look too much into the number, but that's kind of what it is. So, so that's all good. Well, so how do we kind of leverage that in Zeppelin? So I'm going to go do a quick dive into sort of the architecture of Zeppelin for interpreter group, and then we're going to go dive right into a demo. So in Zeppelin, there is a concept of, so it's a client-server model that's communicating using WebSocket, and there's a concept of an interpreter group where interpreters are actually running in sort of in a collaborative kind of manner where there's data sharing that could happen. In this case with R, it's actually going and interacting with another separate OWL process that's actually running standalone, but it's interchanging information between the two. So, it's an interesting way that's how everything is also integrated, but also running something, the OWL process in a separate process. So let's see. I want to go quickly switch to my demo here. So this is Zeppelin notebook running on my machine. So I'm going to go back and quickly touch on that, but you can do all of that yourself. So I have everything sort of shared on GitHub that you can actually run it relatively quickly, setting up the prerequisite and stuff like that, but I'll get back to it in a bit. So this is the main interface. You will go here and click on the R notebook here. So I'm going to go actually switch to this notebook. I'm going to run this just to make sure things are running. So, but back to this, from here you can see all the interpreter binding, which we have quite a few. You actually have all of that stuff plugged into Zeppelin. But going back to Spark, there's a bunch of things you can use with it. The Scala version with Spark, the Python version, the SQL query. In this case, SparkR is also part of that. But there's all these settings you can also set from here. So you can exit from this and go back to this, and there's, you create a new notebook here. That's usually how you go. And then now this particular cell finished. So I want to actually start with a couple of real life data set. So in this case, we're looking at retail employment data from 2008 to 2014. I'm actually having this code here, actually fetching that data from GitHub, but from a website that's actually released by NPR. So it's running. This is actually our code. Not sure you can tell, but basically reading a CSV file from this HTTP address. Building a data frame, which is in this case is actually an R data frame, not a Spark data frame. But we'll get back to the Spark part of it. And then I do a little bit of a data cleaning, converting into like appropriate date type from here. And in this case, I'm actually printing out some of the a subset of data just to give you a view of what it looks like. So, but the last part here, I'm actually using a really popular package, our package called ggplot. Using that to plot, the graph. So, and I'm going to go run this, which will give you a really nice little diagram. I don't know whether you can see the subtle color differences, but there's a range of color for different data points here. And this is actually like a regression, so to try to fit this into sort of a model for the data point. So you can kind of see how it changes throughout the year. In terms of number of jobs and things like that. So we're still working with R only in this notebook. So for the second data set, one of the things R is really good about is there's a lot of packages that's already in there that you can actually use for just playing around with the data set that's available. So in this case, this is all the flights that depart New York City in 2013. So the way you work with this is you just kind of load this library, and then you can print out, again, a subset of data. You can get a few of different columns or different data type that's available and what it looks like. It looks like tail number is sort of like a flight number, that sort of stuff. So right now I'm going to also use another popular library called dplyr in R to work with the data set. So before then I have the flights, right? And then right now I'm using, the dplyr library to do a filter on this. So what I can do also here is just for dramatic, just to showcase that it actually works, and I'm not making up the result here, which is actually really hard to do in Zeppelin, by the way. But I can just change it to whatever month I want, and then I'll say, hey, it would be filtering out the content that was there. Well, I guess two actually take priority. Anyway, so I'll change it back to this, and then I'll print it out again. So this is kind of the iterative part of using a notebook or using repos. You can actually change the query. You can get a feel of what it looks like. Oh, I don't want the month being the first of the year. I want to change it and go back and change it, that's a really easy way to work with data here. The other thing you can do using dplyr is using this mutate method. Basically, you can take a column in this data frame and just kind of start messing with it. Let's just say, hey, I want to figure out the delay and departure time and come up with a new way of measuring these things. Right? Notice how the gain column is there, but it's not shown here because we just have too many columns here. But these things could be calculated. It could be, say, okay, well, the distance is this, and it took so long, and then so the speed for the travel for that flight is such and such. So you can add you can enrich your data set this way. So we're going to be very quickly going to SparkR, but the one last thing you can do with dplyr is you can do all these aggregation and use the result of these to do a visualization. So let me quickly run this. It's going to calculate, the average distance and average delay and all these other things and render into a diagram, which I'm going to show in here. So as you can see, so that's a part with data science and so on, and you want to actually see and get a feel of what it looks like. So in this case, it looks like a lot of flights are within 500 miles. And then most of the delay is kind of, around that distance, basically, right? And then, there's many different things you can do with this data set. You can go back and kind of add additional, data points and do we want to do smoothing of the data set and get some kind of average on the numbers we're seeing and get a better feel what it looks like, that sort of thing. There's many different things you can do. And the reason why I talk about dplyr and all that is there's a reason for that. And the reason why is because SparkR in the first release really aimed to have parity for the dplyr interface. So most of these methods you've seen before, summarize, arrange, where, filter, all that is available from SparkR in the previous release, 1.4 release. So you can do things like, take a data frame, in this case a Spark data frame, and do a group by, and then doing some kind of mapping, mutation of the row, and then doing some conversion here, and then you get basically the result at the end of it. In addition to the dplyr-like methods, you also get like data access APIs. So there are things you can use to load data frame in various different formats. Could be JSON, could be CSV, or even Parquet. The nice thing about this is actually leverage the Spark data access API. So it's a portable model, and we're going to be doing a quick demo of that. So I'll show you in a bit. The very last thing also, which is part of this demo quickly, is you can run a SQL query with this as well. So let's quickly run through this. So in this case, I have a native OWL data frame and converting it using the create data frame API from Spark. So what I do is I construct a very simple data frame with two columns, basically with the name and age and a number, and I'm creating a Spark data frame with it, and using this API to print out the structure of it. So in this case, it has name and number, and so on. The other thing you can do is you can do one of these other readily available data frame data set in R, which is, in this case, is actually the eruption and the waiting time for Old Faithful in Yellowstone. So this is kind of measuring the eruption time. So, and then there's a bunch of other things you can do with this. So first of all, I create a data frame using the native OWL data set. I show you basically the first piece of the content available, just gonna get a feel of what it looks like. And then what I also do is I do a filter on it. This is actually one of the new R-like APIs that's available first in Spark 1.50, which is released today, this morning. So you can do filter to say, hey, any eruption time, number of eruption that's greater than 3, and then I want to only look at the weighting, the column. So in this case, that's a second data set. So you can see anything 1.8 sort of disappear all that, right? So you get 79 and 74, that sort of stuff. You can do all sort of interesting things with it. There's other thing you can do is you actually do transformation, which is kind of similar to, it's essentially the same as mutate that we look at, but I want to show you a different API. So in this case, you can add additional column that's sort of like dividing this by 2 and whatever things you want to think about. Maybe do an average on the previous column, that sort of thing. So, so moving on, and remember the New York departing flight 2013. So the same data set, you can actually get it off this web location. So I'm actually running a shell interpreter shell within a Zeppelin. So what this does is actually running a shell script that actually get this data set from this website. It's a CSV file. The other thing I want to show you is next after that, I'm using one of these Spark packages for parsing CSV file using the SparkR data frame data access API. So the way this works is you can actually load this package as you run this command. What it does is it's going to go and read this data set that's actually local using this library that actually understands how to interpret the CSV file. And then you can see, because the CSV file actually has a header line, so all the data structure is already there. Like you can see all the different columns are correctly named because it's already on the first line of the file itself. So moving on here, and so the same thing we can do with dplyr, with the summarize and means and all that stuff. And so you can see the syntax of this is actually really similar to what we've been through with dplyr. So the same thing actually works. I'm going to skip over that a little bit. The other thing you can also do here is the same dplyr API with filter, arrange, all these things also works. And then one thing that's kind of interesting is that there's a native R library called MapReader, and what it does is basically it allows you to use output of one operation and sort of kind of like piping in a script shell, so you can actually pipe the output of this to another operation and so on and so forth. So instead of having these multiple lines and actually storing intermediate data, that sort of thing, and figure out how to arrange it, you can actually have one single line that does multiple operations in this case. So you can see it gives you the same result set with kind of less cluster, and it does also make it easier to understand, kind of like, okay, you do a filter and then you do a group by from the result of this, and then you summarize based on the cap of the destination, that sort of thing. One more thing I want to talk about is like I said, you can actually run also a SQL query. So what you do is you can take the same data frame and then register it as a table, and then you can run a query on this. So you can do all sort of things you can think of. You can group by, you can order by different things. You can do some aggregation here. You can sum the total number of delays. In this case, I'm saying, okay, it should be called total number of arrival delay, and add all of that together and see, what are we getting at. And I'm also sorting by the destination and so on. So you get a feel like, hey, I want to play around which airport has the longest delay, that sort of thing. You can play around with it, and you can do it in, experiment with it, go back and change it, and that sort of thing. It will also work. One last thing, actually, before we jump back to kind of wrapping up this presentation, is that one of the new things on Spark 1.5 is that you could actually take a data frame. In this case, I'm again taking another native R data set, converting it into a Spark data frame. But then I could also take the content and then running like a linear model. It's like a machine learning model. In this case, a very simple generalized linear model on top of the data set, and using that to predict sort of like new inputs we have. So under the cover, this GRM is actually not an R function. You can do the same thing in R, but in this case, because it's actually working with Spark data frame, this is actually, in fact, a Spark method that actually talks to Spark MLlib under the cover and do this machine learning in a scalable kind of manner, in a distributed scalable manner. This is actually one of the new things, and actually going forward is what we're hopefully going to see more and more MLlib functionality showing up in R as well. So that's the result. And then just quickly touch on, you can also do in the R notebook, like you define your own function, you call into it. You can also take the data set and do additional graphing like something like this. So it's very fancy, you can do whatever you want with it. So let me quickly jump back to, and before we go, since we were running Spark, the same setup I have, you can actually also look at the very new Spark UI, which show you, in addition to the configuration settings you have, amount of memory, that sort of thing, you can also dive into like detailed breakdown of your job and how much, if they're succeeding or moving, that sort of thing. I only have a very simple job here, but that's sort of give you an idea that you can access it through the setup I have as well. So that brings me to I'm running full screen, am I?
I have a question.
Yep.
Is the Spark UI something recently added or?
Spark UI has been improved quite a bit in the last release or so. Right now, and you really encourage you to actually look into it, but it will show you basically the DAG, how different step of processing your data set, so you can dive into details like amount of memory allocated, time spent, so you can fine tune your workload and understand a little more about, hey, maybe this operation is very expensive because it's doing a lot of shuffle and that sort of stuff. So it's been improved quite a bit, and also there's been more improvement around the streaming integration. So if you have a Spark Stream job, there's nice visualization in terms of what your job is doing, that sort of stuff. Spark UI, that page I showed you, it's been there for a long time, but it's been improved quite a bit. So one thing, just maybe two more slides here. Basically, what I want to also touch on is everything you see here, what I ran, you can do it yourself. Everything is in GitHub. I'm using a Vagrant VirtualBox setup that have this provisioning script that automatically set up all the stuff that you need. The JDK on a VM, the R, the version of R I depend on, and also all the R packages that was used in the demo. It also automatically download the 1.5 release, so you don't have to worry about it. It just run it, and everything will be set up, and you can actually start running Zeppelin on top of that. Well, the only thing, actually, a catch here, the only thing that it doesn't do is build you Zeppelin. So, and feel free to reach out to me if you have a problem with it, but as soon as we integrate the SparkR interpreter, I think it will be much easier to use going forward. So you can actually just use the script, and everything will be set up. So last few slides, one thing here is what's new, just to recap, what's new in the setup, in this demo. So we're running a very new change in Zeppelin that works with a existing Spark installation, Spark build you have on the virtual machine, or the virtual machine that I have. So, and that's actually one of the key reasons why I was able to actually run Spark 1.5 because it was just released today. So everything just works, which is great. And then again, like I said, we're running Spark 1.5 and also some of these SparkR API, which is kind of these stuff. Just to recap, within Spark 1.5, there's SparkR support for these R formula that you can use for machine learning model. So this is very extremely handy. Even if you're doing just simple GLM or k-means, that sort of thing, our formula, I encourage you to look into it. It's a really powerful way to basically build your feature set that's used in the machine learning model. The other thing I want to also mention is some of these API that was added in Spark 1.5 allow you to work with data in a more intuitive kind of manner. You can do subset or select on the data set to say, hey, I want to care about ages within this set that I have, and I want to slice it in different ways. Say, hey, I only need about these two columns, that sort of thing. the power is there. You can actually do all of that pretty easily. One more plug at the end is Zeppelin is moving really quickly. We're gonna have more and more feature coming in, and there's a lot of really cool stuff coming in the upcoming 0.5x release, whichever that number is. Hopefully in the next week maybe, sometime. And the 0.6 release, which is coming up at some point. So that's it for me. So any questions? My address is there. You feel free to get in touch with me. If you have any questions about my presentation or Moon's presentation, feel free to ask away right now. So, yes?
Yeah, in the example you were showing, where you have a SQL query embedded in the R code.
Yeah.
If you had created two separate data frames
Yeah.
And realized them both as tables,
Yeah.
Can you join across those?
Oh yeah, absolutely. So the idea is, so the way to do this is you can actually register both as using the register timetable API, and then you can write your own, like basically a SQL query that says, hey, join this table versus this table. That would be the SQL way of doing it. You can also take the data frame and actually join the data frame as well, using the API basically. So both ways work. So if you're more SQL inclined, you can do it completely in SQL and join it like that.
Okay.
So, in fact, that also works in Scala or Python, but R in this case, you can also do the same thing.
Okay.
It's weird. Yes.
So R typically has the memory constraint issues where it loads up all the data nicely into memory. When you're using a native, I assume in the code there, when you're using a native Spark data frame, then you're able to use RDDs and go beyond those, sort of exceed those limitations. But when you're using a native R data frame, you still have those limitations there.
Oh yeah. So the caveat here is you need to be mindful of whether you're using a Spark data frame or a native R data frame. I mean, it gets a little blurry, maybe a little confusing at times because how they look really alike, I guess, in the way that you're using it, which is kind of plus or minus, depends on how you look at it. But yeah, like the way it could work possibly is you could call a collect method like you would be able to do in Python or Scala with Spark and collect all of that into a local native R data frame and then work with it, with the caveat that now it needs to be fit in the memory. So the really common way of doing it is you do your scalable manipulation using Spark, and then do the aggregation, and you leveraging Spark as a way that you can deal with data in a scalable kind of way, and then down to a point where you're happy with it, you might want to be able to collect it and then do some visualization on it locally on your box. So that's a common way of doing it. So. Yep.
I had a basic question. The
Sure.
R that you showed there, do we have control on what version of R will be running in the backend? What's that linkage? Does it just pass through the commands to the R?
So, yeah, the version of R or the version of SparkR?
Just R.
So there's a range of R version that's actually supported by Spark. So it has to be 3.1 R or above. But the way they interact with each other is just simply by name. So you would launch R, whatever shortcut or path you have set up, it will just run the R, and then it will just run the library. So anything that's compatible with the SparkR package would work fine. Was there a specific problem that you have, like a specific version of R?
The reason I asked the question is because some of the packages, they're not really up to the latest version release of R.
Right.
Sometimes you have to go back a few versions so that you get the right package.
Yeah, that definitely is a problem. So the good thing is it only requires 3.1, which is not terribly latest. It's not the latest version. That's the minimum version that's actually required. And then SparkR itself, you can actually load it in whatever favorite tool you have, like RStudio or whatever that is, like this. There's actually a little bit more detail than that, because you need to set up the lib path or something like that. But I just sort of skip over it. But you feel free to reach out to me if you want to know how to use it. One thing that's very nice about this is if you have Spark on your machine, if you run these code and then using the SparkR script or that sort of thing, you can pretty much just run it right away. And there's no prerequisite on it. It doesn't need to be installed or anything like that. You just run it off your Spark home, which is like running off the Spark home is all that's required. So if you set up your Spark home and then you have sort of roughly the right version of R, then you can run these commands and also use Apple to actually run it like that too. So it works very nicely.
Thanks.
Any other questions? So feel free to talk to us individually if you have any further questions, but otherwise that's it. Thanks for coming. Appreciate it.